Article 700 of the National Electrical Code addresses emergency power systems. A key requirement within this article is the maximum allowable transfer time for emergency power in essential facilities like hospitals. The transfer time refers to the duration between a normal power outage and the complete switchover to an emergency power source, typically a generator. For hospitals, the NEC mandates that this transfer must occur in less than 10 seconds. This stringent requirement is directly linked to patient safety and the need to maintain critical life support systems without interruption. A prolonged power outage, even for a few seconds beyond the 10-second limit, could have serious consequences for patients relying on electrically powered medical equipment. This includes ventilators, heart monitors, and other essential devices. The design and implementation of emergency power systems in hospitals must prioritize rapid transfer times. This involves careful selection of transfer switches, generator sizing, and overall system architecture. Regular testing and maintenance are also crucial to ensure the system performs as intended during an actual power outage. Electrical engineers and facility managers must be thoroughly familiar with Article 700 and its specific requirements for emergency power systems in healthcare facilities. Compliance with these codes is not merely a regulatory issue. It is a matter of life and death for vulnerable patients. Understanding the nuances of Article 700 is essential for ensuring the safety and reliability of emergency power systems in hospitals. This involves careful consideration of various factors, including the load requirements of critical equipment, the available backup power sources, and the specific characteristics of the electrical distribution system. The 10-second transfer time requirement applies to systems that serve what the NEC defines as essential electrical systems. These systems are divided into several branches. Firstly, the life safety branch supplies power to systems such as emergency lighting, fire detection and alarm systems, and communication systems. Secondly, the critical branch provides power to critical care areas, operating rooms, and other essential medical equipment. Thirdly, the equipment branch shares equipment necessary for the safe shutdown of operations. Meeting the 10-second transfer time requirement necessitates careful selection and coordination of various components. This includes generators, automatic transfer switches, and uninterruptible power supplies or UPS. Generators must be sized appropriately to handle the connected load and must be capable of starting and reaching full speed quickly. Automatic transfer switches must be designed to rapidly and reliably switch the load from the normal power source to the emergency power source. UPS systems can provide a bridge during the transfer time, ensuring an uninterrupted power supply to critical equipment. Regular testing and maintenance are crucial to verify the proper operation of emergency power systems. Testing should include simulating a power outage and verifying that the generator starts and the transfer switch operates within the required 10-second time frame. Maintenance should include inspecting and servicing all components of the system, including the generator, transfer switch, and batteries. The NEC Article 700 provides detailed guidance on the design, installation, and testing of emergency power systems. It is essential for electrical engineers, contractors, and facility managers to be thoroughly familiar with these requirements to ensure the safety and reliability of emergency power systems. Failure to comply with the NEC can result in significant penalties, including fines and legal action. More importantly, it can jeopardize the safety of patients and staff. In addition to the 10-second transfer time requirement, the NEC Article 700 also specifies other requirements for emergency power systems. These include requirements for the location of emergency power equipment, the type of wiring used, and the overcurrent protection provided. Emergency power equipment must be located in a room that is protected from fire and other hazards. The wiring used for emergency power systems must be fire resistant and must be separated from other wiring systems. Overcurrent protection must be provided to protect the emergency power system from damage due to overloads and short circuits. The NEC Article 700 is a comprehensive standard that addresses all aspects of emergency power systems. Compliance with this standard is essential for ensuring the safety and reliability of these systems. It is important to note that the NEC is a minimum standard and that local jurisdictions may have additional requirements. It is always advisable to consult with local authorities to ensure that emergency power systems comply with all applicable codes and regulations. The design and implementation of emergency power systems is a complex task that requires specialized knowledge and expertise. It is essential to work with qualified electrical engineers and contractors who have experience in designing and installing these systems. Proper design and installation are crucial to ensure that the emergency power system will operate reliably when needed. Regular testing and maintenance are also essential to ensure that the system remains in good working order. Emergency power systems are a critical component of any hospital's infrastructure. These systems provide backup power to essential equipment and systems during power outages. Proper design, installation, testing, and maintenance of emergency power systems are essential to ensure the safety of patients and staff. Understanding the requirements of the NEC Article 700 is crucial for anyone involved in the design, installation, or maintenance of emergency power systems in hospitals. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. Changes to the NEC can have a significant impact on the design and installation of emergency power systems. It is important to review the latest edition of the NEC to ensure that emergency power systems comply with all applicable requirements. In addition to the NEC, there are other standards and guidelines that address emergency power systems. These include standards from organizations such as the National Fire Protection Association or NFPA and the Institute of Electrical and Electronics Engineers or IEE. These standards provide additional guidance on the design, installation, testing, and maintenance of emergency power systems. It is important to be familiar with these standards to ensure that emergency power systems are designed and installed to the highest standards of safety and reliability. The cost of installing and maintaining an emergency power system can be significant. However, the cost of not having an emergency power system can be even greater. A power outage can disrupt critical operations, jeopardize patient safety, and result in significant financial losses. Investing in a reliable emergency power system is a wise decision that can protect a hospital from the potentially devastating consequences of a power outage. The 10-second transfer time requirement is not the only performance requirement for emergency power systems. The system must also be capable of providing power for a specified duration. The NEC Article 700 specifies the minimum duration for which emergency power must be provided. The duration depends on the type of facility and the criticality of the loads being served. For hospitals, the minimum duration is typically 2 hours. However, some hospitals may require longer durations depending on their specific needs. The emergency power system must also be capable of providing power at the required voltage and frequency. The voltage and frequency must be maintained within acceptable limits to ensure the proper operation of equipment connected to the emergency power system. Voltage and frequency fluctuations can damage equipment and can also cause it to malfunction. The emergency power system must be designed to minimize voltage and frequency fluctuations. The emergency power system must also be protected from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, must be installed to protect the system from damage. The overcurrent protection devices must be sized appropriately to handle the expected load. The emergency power system must also be grounded properly. Grounding provides a path for fault current to flow back to the source, which helps to protect equipment and personnel from electrical shock. The grounding system must be installed in accordance with the requirements of the NEC. The emergency power system must also be inspected and tested regularly. Inspections and tests help to identify potential problems before they can cause a power outage. The inspection and testing program should include visual inspections, electrical tests, and functional tests. The results of the inspections and tests should be documented and maintained. The emergency power system must also be maintained properly. Maintenance includes cleaning, lubricating, and replacing worn parts. Proper maintenance helps to ensure that the system will operate reliably when needed. The emergency power system must also be operated properly. Operating procedures should be developed and followed to ensure that the system is operated safely and efficiently. Operating personnel should be trained in the proper operation of the system. Emergency power systems are a complex and critical part of a hospital's infrastructure. Proper design, installation, testing, maintenance, and operation are essential to ensure the safety and reliability of these systems. Understanding the requirements of the NEC Article 700 and other applicable standards is crucial for anyone involved in the design, installation, maintenance, or operation of emergency power systems in hospitals. The specific requirements for emergency power systems can vary depending on the type of hospital and the services it provides. For example, a large teaching hospital may have more stringent requirements than a small rural hospital. It is important to consult with qualified electrical engineers and contractors to determine the specific requirements for a particular hospital. The design of an emergency power system should take into account the hospital's existing electrical infrastructure. The emergency power system should be integrated seamlessly with the existing system to minimize disruption during a power outage. The emergency power system should also be designed to be easily expandable to accommodate future growth. The installation of an emergency power system should be performed by qualified electrical contractors. The contractors should have experience in installing emergency power systems in hospitals. The installation should be performed in accordance with the requirements of the NEC and other applicable standards. The testing of an emergency power system should be performed by qualified testing personnel. The testing personnel should have experience in testing emergency power systems in hospitals. The testing should be performed in accordance with the requirements of the NEC and other applicable standards. The maintenance of an emergency power system should be performed by qualified maintenance personnel. The maintenance personnel should have experience in maintaining emergency power systems in hospitals. The maintenance should be performed in accordance with the manufacturer's recommendations and other applicable standards. The operation of an emergency power system should be performed by qualified operating personnel. The operating personnel should have experience in operating emergency power systems in hospitals. The operation should be performed in accordance with the manufacturer's recommendations and other applicable standards. Emergency power systems are a vital component of a hospital's infrastructure. These systems provide backup power to essential equipment and systems during power outages, ensuring the safety and well-being of patients and staff. Compliance with the NEC Article 700 is paramount for ensuring the reliability and effectiveness of these systems. Understanding the intricacies of this code, along with other relevant standards and guidelines, is essential for anyone involved in the design, installation, testing, maintenance, or operation of emergency power systems in hospitals. The 10-second transfer time requirement serves as a cornerstone of patient safety, underscoring the critical importance of rapid and seamless transition to emergency power in the event of a normal power failure. Regular testing and maintenance protocols are crucial for validating the system's readiness and ensuring its ability to perform as intended when needed most.